this. So let's see what happens. Okay, so it takes some time to load. Just notice that, and then we ask it again. And now just notice how it gives the answer. Yeah, it might take a long time. And okay, so did you notice something? The previous one was like immediately it was giving an answer. Here it seems like for every word it has to work hard. हर word में थोड़ा सा मेहनत करना पड़ रहा है, थोड़ी थोड़ी देर के बाद आ रहा है. This is not what you're used to in modern computing, right? Everything is extremely quick, and this is supposed to be the state of the art thing. And they're sort of this you don't see on the ChatGPT interface, right? So you'll see why that doesn't happen and why it is happening like this here. It's the same model. It's actually a simpler model than ChatGPT, and it's running so slowly. It's giving correct, reasonably correct thing, but yeah, like each word it has to sort of work hard for. So you see, so there are these two. So already I've seen something. It took a long time to load the model, and this laptop is a decent laptop. It's not like a old laptop. It's a decent laptop. It still took a long time to load, and then even to produce one word, it is taking a long time. Okay? So these two things are good to remember. Okay, so coming back, so what all of these models, this one was Llama, it's not written here, they all depend upon a technical advance. Like they all use the same, like variation of a similar thing, which is called GPT or generative pre-trained transformer, whatever that is, we'll come to. So this is some kind of a machine architecture one can think of. कोई machine का एक architecture जैसा है जिसमें चेंज कर करके अलग अलग मॉडल बनाए जाते हैं और फिर देखा जाता है कि वो क्या उसमें कैसे मतलब कोर्स सब में अंतर है. कोई किसी चीजों में चैट जीपीटी ज्यादा अच्छा रिस्पॉन्स देता है, किसी चीजों में क्लॉड ज्यादा अच्छा रिस्पॉन्स देता है. तो अंतर क्या है वो कैसे आते हैं वो तो वो भी देखेंगे. लेकिन ये एक चीज है, ये generative pre-trained transformer, whatever that is, which has somehow been the bedrock of all of these advances. So here is what the transformer in that thing means. So it is this picture. What is this picture? So every box in this picture, जिसमें जितने भी बक्से से बने हुए हैं, they are all collections of numbers. इसमें ढेर सारे numbers हैं, बहुत ढेर सारे. तो कितने वो भी अभी देख. तो जिसमें 3 बिलियन लिखा होता है ना में 3 बिलियन, वो ये बता रहे हैं कि कितने नंबर हैं टोटल. तो 3 बिलियन, 3 अरब, तो 3 into 10 to the power 9. So that many numbers it had. So each of these things contains a bunch of numbers, and then these numbers are used to calculate. So basically you give the input, जो हमने क्वेश्चन पूछा, वो क्वेश्चन को लेता है, उसको नंबर्स में पहले कन्वर्ट करता है, फिर उसके ढेर सारे कॉम्पिटिशन करता है. वो नंबर यहाँ इनपुट में आता है, फिर उसके बाद उस पर वो कुछ कंप्यूटेशन करता है, फिर वो आगे वाले को भेजता है, वो आगे वाला उन नंबर्स पे फिर से कंप्यूट करता है जो उनके पास नंबर है उसको लेके, फिर उसके आगे भेजता है, फिर इस तरह से ये पूरा. और ये जो एक है ना, ये इसका इनपुट इसी तरह के एक और में जाता है. इस तरह से 5-6 ऐसे डेप्थ में ऐसे लगे होते हैं और फिर इस तरह से वो काम करता है. तो ये सारी जो चीजें उसमें ढेर सारे नंबर्स हैं, वो नंबर्स जो इनपुट में जो नंबर आ रहे हैं उनसे उनके ऊपर ऑपरेट करते हैं और फिर उसके बाद वो अगले लेवल के लिए आउटपुट बनाते हैं, फिर अगले लेवल जो पिछले इनपुट को लेके फिर अगले लेवल के लिए आउटपुट बनाता है. इस तरह से और अंतिम जो लेवल है उस पर आउटपुट मिलता है. और फिर इसमें एक और चीज है कि यहाँ पे लिखा है शिफ्टेड राइट. इसका क्या मतलब है, जो पिछला आउटपुट आया है उसको फिर से इनपुट में फीड किया जाता है, क्योंकि जब आप बात कर रहे होते हैं तो आप एकदम इंडिपेंडेंटली नहीं बात कर सकते ना. जो आपने पहले बोल चुके हैं उसके आधार पर अगला शब्द बोलेंगे. तो ये चीज इसको भी देखना है. तो वो जो पहले जो आउटपुट दे चुका है वो भी उसका इनपुट है, पहले जो वर्ड बोल चुका है उसको भी उसको अकाउंट में लेना है और तब आगे वाले शब्द बोलना है. ओके, so this is what this not transformer. This is what a transformer looks like. It's a neural network. Okay, these things are just called neural networks. These are just names. What a neural network is, it's just a collection of numbers arranged in some way. और वो नंबर्स क्या करते हैं, जो इनपुट आता है उनको नंबर्स आगे प्रोसेस करते हैं, फिर उसके बाद जो आगे के नंबर्स होंगे वो उनको प्रोसेस करेंगे और इस तरह से चलता है. तो ये और ये फिर तो ये सारे तो अब कम से कम ये लग रहा है कि क्यों इतना टाइम उसको लग रहा था. 3 बिलियन पैरामीटर्स, तो कितने नंबर्स, 3 into 10 to the power 9 नंबर्स टू प्रोड्यूस ईच वर्ड, ईच ऑफ दीज नंबर्स. जितने भी नंबर है सबको उसमें योगदान देना है. आपका जो प्रोसेसर है उसकी जो क्लॉक स्पीड होती है, आपने सुना होगा गीगाहर्ट्ज, 4 गीगाहर्ट्ज, 3 गीगाहर्ट्ज ऐसे. उसका क्या मतलब होता है कि वो लगभग 1 सेकंड में कितने इंस्ट्रक्शंस, वो कितने कैलकुलेशंस कर सकता है. 3 गीगाहर्ट्ज का मतलब है लगभग 3 3 अरब 3 × 10⁻⁹ ऑपरेशन। यहाँ पे उसको 1 सेकेंड में वो सारे नंबर्स, वो 3 बिलियन जो नंबर्स हैं, वो सारे सारे नंबर्स के साथ सारे नंबर के साथ कैलकुलेशंस करने हैं। अगर 3 बिलियन नंबर है तो कम से कम 3 बिलियन कैलकुलेशंस भी हो रहे होंगे, हर कैलकुलेशन में कुछ कुछ 1 2 नंबर ऐसे जोड़ते जा रहे होंगे। तो उतने सारे कैलकुलेशन करने के लिए उसको एक एक बार मॉडल को चलाने के लिए कम से कम 1 1.5 सेकंड की जरूरत होगी, अच्छे डेस्कटॉप पर भी, अच्छे लैपटॉप पर भी। तो इसलिए वो एक एक वर्ड लाने में इतना टाइम लगा रहा था। वो बहुत बेसिक चीज है, वो उससे तेज कर भी नहीं पाएगा। लेकिन चैट जीपीटी तो उससे तेज करता है ना, आपने देखा होगा, अगर आपने किया तो वो बहुत जल्दी से करता है। तो वो भी हम देखेंगे कि वो कैसे होता है। तो अभी तक कोई क्वेश्चन है, अभी तक कोई प्रश्न? जैसे कि सब। हाँ। हाँ, किस?
First I read them showed that when you ask the question that which like, is alarm clock or
हाँ,
all the web are they a machine?
are they talking? Yeah, are they talking? Yeah, yeah. They are all machines, let's say, for us, but are they talking? No, no. What is an AI? Yeah, okay, that's a very good question. So, is an AI a machine? So what is a machine? Let's first ask that question. So what? Okay, so what is a machine? So you must have done something in your class 6 physics or something, right? So there maybe there's a very narrow definition of a machine. It has to convert. I forget also, maybe I'll get it wrong. Work from this to work from to work done in one place to work done in another place. But in general, a machine should be seen as something like this. It mindlessly does what it has been sort of designed to do. It has been designed in the beginning, and then it just does that. So a clock has the circuit inside it, and the circuit will do whatever it was designed to do. एक इनपुट आएगा उसमें, वो टाइम जब सेट हो जाएगा तो उस पर वो क्लॉक बजेगा. It will not do anything else. It will not suddenly start doing something else. By this definition, any such AI is a machine. क्यों? क्योंकि उसमें क्या, someone has written a code, some numbers have been fed into it somehow. So this we will see how these numbers are fed in. Once these numbers are fed in, nothing else is going to happen. Its behavior is completely determined by these things. Inputs will come, it will process those inputs in that thing, and then it will output. So that is a machine. For us, a machine is something which there is some design and there is some input, and when the input comes, it processes the input according to the design and then gives an output. Now, by this definition, now the philosophical question might be that is a human being a machine? So this I will not try to answer. Yeah, so this is like one sort of fundamentalist question can be that yes, like by this definition, yes, that this could be true, but you have to, yeah, maybe one has to think more carefully about what. But that is a machine. So yeah, all these AIs are machines. So yeah, AI is just a fancy name for a certain kind of machine. Okay, so we'll actually, yeah, so we'll see, like we can also write our own AIs very soon. Yeah, it's not. Okay, so this is what a neural network is. It has this bunch of numbers and so on. So, but let's look at a very simple neural network that all of you probably have seen. By the way, so maybe I should just say that this neural networks, etc. They won the so this idea, the advancements that led to neural networks won the Nobel Prize in Physics. It was awarded to John Hopkins and John Pington last year. But for us, let's actually look at a very simple neural network. This I'm sure everyone has seen, or at least everyone who is in class 9 or above has seen. So you will probably have some labs. Probably you're measuring some. You take some kind of a wire and you're measuring voltage across it and the current flowing through it, and you're trying to you try to measure its resistance. And then when you do that, the kind of measurements you make are like these blue points, right? So you maybe, so I've not said what X and Y are. Maybe one of them is voltage, one of them is current. You get some points and you put them on a graph paper. And then your textbook or your teacher tells you that you have to now fit a line to it. Okay? You fit a line to it to get your resistance. What does fitting a line means? You try to write down, draw a straight line which sort of captures whatever these points are doing. Okay? ये मतलब ये कि जैसे ये points लगभग line पे लग रहे हैं, कुछ कुछ इधर उधर भी है, लेकिन fit करने का मतलब है कि एक ऐसा line बना है जो 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 लगे कि वो ये सारे पॉइंट इसी लाइन के ऊपर थे, लेकिन थोड़ा इधर उधर हट गए हैं क्योंकि कुछ मेजर करने में एरर हुआ या कुछ ऐसा हुआ. तो ये जो लाइन वाला यहाँ बना हुआ है नारंगी वाला, वो क्या फिट है? वो अच्छा फिट है या उससे अच्छा फिट हो सकता है? हाँ, उससे अच्छा हो सकता है ना. It is certainly clear that it can be done. And of course, because you are a human being, you will immediately say what you want to do. Something, some line like this. But you want a machine to do it, right? And this machine has the following inputs. It has this data, and what it is trying to do is that it has these two sort of parameters. Instead of so many billions of parameters, billions of numbers, there are just two numbers, A and B. Okay, and it has to find these A and B to fit. Okay, so how does it try to fit? Okay, so here is what it does. So it says that so it actually does something very similar to what is done in schools, right? Or at least what is supposed to be done in schools. You say that it is trying to learn this A and B. So what will it do is that it will say, okay, I have learned A and B. This is my A, this is my B. Then someone will come and say, okay, you have learned this A and B, so let me test you. हाँ, उनकी परीक्षा होगी. तो क्या तो हर एक्स आई के लिए एक वाई आई था, ये जो नीले नीले पॉइंट थे. तो हर उसके लिए उसका एक स्कोर बनाया जाएगा. तो ये कैसे स्कोर बनाया जा रहा है कि ए और बी था, तो आपने ए एक्स आई प्लस बी जोड़ा और वाई से उसको सब्ट्रैक्ट किया. तो अगर एकदम अच्छा होता, एकदम ए और बी एकदम करेक्ट होता, तो ये नंबर 0 होना चाहिए था या 0 के पास होना चाहिए था. बट इट इज नॉट क्लोज टू 0, so you square it. You square it because होता है वो नेगेटिव वो पॉजिटिव, वो दोनों ही खराब है. तो आपको एकदम जहां तक हो सके उसके पास चाहिए. तो आपने उसको स्क्वायर कर दिया, उसका सबका ले लिया सारे पॉइंट्स पे, एन पॉइंट्स है सब पे आप. तो ये एक स्कोर है, इसको और इससे फिर माइनस साइन है. तो माइनस साइन क्यों है? तो जितनी ज्यादा आप गलती कर रहे हैं, आप नेगेटिव मार्किंग हो रहा है, तो उसका नेगेटिव स्कोर उतना उसको मिल रहा है. हाँ? जितना ज्यादा वो दूर है उतना उतना ज्यादा नेगेटिव उसका स्कोर है. फिर उसको बताया कि देखो तुम्हारा ए और बी जो ऐसा था, उससे आपका जो ए और बी था उसमें आपका स्कोर इतना आया है. तो अब वो मशीन को क्या करना है कि दिस हैज टू बी डन समहाउ. कि मशीन अच्छा मेरा तो ए और बी ऐसा था, मेरा स्कोर इतना नेगेटिव आया, तो मुझे थोड़ा सा ए और बी को चेंज करना चाहिए किसी दिशा में. तो ये उसको पता चलना चाहिए. सो द मशीन शुड लर्न which way to change A or B. It will try to change A or B to maybe slightly, hopefully improve its score. So it will change A and B somehow. We'll see how. Then again, this tester will come and whatever exam board, whatever will come and say again give a score. अब आपका स्कोर इतना है. So again to say okay स्कोर अभी इतना हुआ, अच्छा है कि नहीं अच्छा है, तो फिर ठीक है, फिर से चेंज करते हैं. So it will keep doing this, and hopefully by doing this, it will come to the correct answer. So let's see if it actually happens. Okay, so let's try this. Okay, so yeah, so here I've just run like so. I have just so this is just some synthetic data that has been generated. So this is the picture that you saw on the slide, and now what we are so the interesting thing that is happening is here. So I will not explain why this is happening. This is basically telling this minus grad, whatever that means. This is actually telling the machine, or this is the part of the machine which says that when I get a score, or how much should I change my A and B? In which direction should I change A and B? Should I increase A? Should I decrease A? Should I increase B? Decrease B? By how much? Maybe I should increase A by 1, decrease B by 1, or maybe increase A by 2 and decrease B by 1. So what to do is what this thing tells it. But it's a very simple thing. It's some function written in Python. It just tells it what to do. And then all the machine has to do is just this. This is very simple, right? So it is saying that there is some, so there's just one interesting thing here called learning rate. So it is saying it has this X and Y, the actual input, जिस पे उसको टेस्ट किया जा रहा है. It has its current A and B. From this, it tries to find out what should be its step. How much should it try to change A and B? In which direction? A को इंक्रीज करना चाहिए, B को डिक्रीज करना चाहिए, क्या करना चाहिए, ये उसको पता चलता है. ये पहला लाइन है. यहाँ पे अगले लाइन में वो क्या कर रहा है, दिस इज इंटरेस्टिंग थिंग. क्या है, ठीक है, मुझे डायरेक्शन मिला AG और BG. मेरा एक्चुअली अभी करंट जो वैल्यू है वो A और B है. आई कैन जस्ट टेक say I will add AG to A and BG to B, A plus AG, B plus BG. But that maybe is something not good, right? Because that is saying कि मैंने पहले भी कुछ पढ़ा था, पहले भी उसने कुछ पढ़ा था, A और B के बारे में कुछ सीखा था, और अब एक गलती हुई तो उसने पूरा वो सब भूल के फिर से केवल इसी को ले लिया, ऐसा कुछ लग रहा है. तो ऐसा करना तो ठीक नहीं है ना. दिस इज नॉट गुड. You had learned something, you don't want to forget that. You still want to keep that in memory, but maybe there are some small errors in it that you want to correct. Okay, so that's what the machine wants to do. So that it does by using learning rate. So the learning rate is small. That is saying that it is whatever this new feedback it is getting from this one test, it is taking how much weight it is giving to this new feedback. It's learning over the whole time, and given this new feedback, how much weight should it give to this new feedback it has just obtained. Okay, so let's try. So here is the starting position, and let's say that we try this 100 times. We do this 100 times and see what happens. So actually, that's if I do 100 times, it does actually get to the right answer. But let me just first try to do it for a smaller number of times. So let's see. So let's say I just do it for one time. So one time, not much changes. One step, not much changes. Let's try 10 times. 10 times it seems to keep getting closer. And if I do 100 times, it seems to get this. I think all of you will agree is a pretty good answer, right? This looks like a pretty good fit. This maybe you should be happy with. The machine has learned. But now you can say, oh, it took this 100 steps. I had to take 100 exams to learn this very simple thing. Why not change the learning rate and make it very high? That seems like the right thing to do, right? Whenever I get a good feedback, just take that feedback with a large weight and use it, right? So let's try to do that also. So let's say, so what should we try to do? Increase the learning rate, right? So this is 1e minus 4. 1e minus 4 just means 0.0001. So there are 3 zeros before. So now what should we do? So if we want to speed up this learning, we want to take fewer exams. So what should we do? Increase the learning rate or decrease the learning rate? Decrease. Increase, right? Change the learning rate to something high. So maybe let's increase it by a factor of 100. Let's see what happens. So if I increase by a factor of 100, it becomes 1e minus 2. And maybe you can already see. So see what happened is this. After one step, this line has just gone way above all the points. Now let's try it once more. So one more step. So one more step. And now the line has gone way below the correct answer. We'll do one more step. Now it has again gone way above the correct thing. Does not seem to be coming to the close to the correct answer. So this is like you might have heard this joke about statisticians that I can maybe make this joke. So the point is that they have gone for shooting, like in Olympic shooting, right? So you have to shoot at a target. So other people try to shoot at the target, and someone said that, oh no, I will shoot 1 meter to the right of the target once and 1 meter to the left of the target once, and then in average I hit the target. This is what this seems to be doing, right? It is one time it's going way above, one time it's going way below, but it's never actually coming to the correct target. So this very fast learning rate, trying to learn very fast, can be problematic, right? This is another thing you see. So even this very simple example, the simplest neural network with just two things, we already see one of the most important part, like notions in modern machine learning or AI as it is called, that you better try to learn slowly. So it's a strange kind of lesson to take, but yeah, whatever new things you are getting, you learn. You don't forget what the old things that you have learned when you look at the new thing. Okay, so that's in a very simple model, and this of course I tried on my laptop. Nothing was there's no problem at all. So what about all this GPU, all these fancy things that we were talking about, Llama and all these things? So let's see. So let's write this down as some numbers. So this model, this neural network that you are just training right now, how many parameters did it have? Right? It had two numbers, just A and B. Its brain was very small. It had just two numbers, A and B. So I'll just do a demo, which will have about 4 into 10 to the power 6 numbers. The llama that we saw is 3 into 10 to the power 9. Okay, so 3 billion or 3 arab, that many parameters. And DeepSeek, that one of the famous models that came out recently, is 7 into 10 to the power 11 many parameters roughly. Okay, so what does these parameters mean? So the thing that you should keep in mind is that roughly, if you have 10 to the power 6 parameters, that is like 4 MB. Everyone knows MB, right? What is an MB? Yeah, so that is how much storage you need, right, for storing some information. So 10 to the power 6 parameters is roughly like 4 MB. So you can imagine like how big these ones are, right? So this llama is, for example, already just small thing, already 2 to 3 GB, 3 GB around at least. And this one you can imagine now how much more it is, right? 300. So let's see this text generation thing. So let's try to write let's try to get a talking machine of ourselves, right? So this is a very like a hackneyed example that as soon as you do any kind of machine learning, you try to do once. So what you do is you take some large body of text. So here I took a collection of Sherlock Holmes stories. Everyone has heard of Sherlock Holmes? Maybe it's there in some school text story or something, right? So this is a collection of stories, Sherlock Holmes stories. And what we want to do is we want to make this machine learn to produce sentences at least or sequences of words that look like they might have come from a Sherlock Holmes story. That's the goal. Of course, we are not. So our goals are modest. We don't want to learn to write stories. We just want to learn to get somewhat close. So to do actually based on some official tutorial, as I said. So let's try to do it on my computer. And what I will do is I will take this story, but I will only look at a small part of it because my computer is not that great. We'll just look at the first 10,000 letters in it and then try to learn based on that. So let's see what happens. So, okay, so we try to fit it. And this epoch is basically how many times it is reading the text. So each epoch, it reads the story, the full set of these 10,000 characters once. So I'm running it for 5 epochs. So you can see it's taking about 2 seconds per epoch. And yeah, it is done. And now I try to generate this text. You can probably see what's going to happen. So I try to generate this text. Yeah, it will take some time. Yeah, okay, you already see that it is taking, yeah, okay, so this is supposed to be its answer. Does it look like this sample number one, does it look like a sentence from a Sherlock Holmes story at all? No, right? It didn't learn at all, learned nothing. And okay, so maybe the reason is it didn't learn anything. Another, here is a number of parameters. This model had 4 million, 40 lakh parameters. It didn't learn anything in 5 epochs, and it was very quick. And okay, maybe it's fine. Maybe what we should do is that we should not have this length limit. So we should not have this length limit. Try to read the whole story, and let me try to do. Now you see what happens. So now something, yeah. So notice what is it saying? The ETA is expected time it will take to do that one epoch. How much is that? 3 minutes. 3 minutes to just read the whole story once, right? And I did 5 epochs with this. That's why I did a smaller thing. Then maybe we'll do something, but clearly this is not what I want to do, right? This laptop, like we don't have, like I have actually exactly 3 minutes. So this is not what we want to do, right? We don't want to do it on a laptop. So let's go somewhere else. So let's let it run. In the meantime, let me do something. Let us go to our high performance computing cluster at TIFR. Okay. And yeah, I've already set it up, so it should just work. Okay, so here I have actually done the training. So you can see it was doing these epochs. I will not run it again because it will take just a little bit of time, but just look at this. Each epoch was taking 3 seconds. The same thing that laptop is saying it will take 3 minutes. Here we're running in 3 seconds. So I will just let it run. And maybe, yeah, it will run and produce some output. But in the meantime, I can show you what output this generates after running these 50 epochs of this in 3 seconds each. So here is what you see. Sorry. So this is some experiment I just ran a little while ago. So, okay, this is what it generated. Does this look a little bit at least much more like the sentence that could come in a Sherlock Holmes story? This is generated by the machine, just on random. So what's that you are now standing in the press? Not quite grammatical, but it's still much better than what the laptop was producing, and much faster. So, okay, so let's see yeah, here you can see it running, by the way, the thing that I just run. So it's doing each one of them in about 3 seconds. each epoch in 3 seconds. So it's running through the whole file, the full set of stories in about 3 seconds. The laptop was taking how long? It was claiming to take about 3 minutes. So the question is, what is this that the HPC has, right? This laptop is not a bad laptop, it's a pretty good laptop. So it has something called GPUs, and this is a graphics processing unit. But I mean, for all graphics, like we are trying to do machine learning, what does graphics and art have to do with it? So the point is this, that when you're running, when your phone is showing something on the screen, or the computer is showing something on a screen, or like when people are doing telemedicine and the image is being rendered on the screen, the calculation that has to be done to render each pixel is essentially the same kind of calculation. So the same calculation has to be done slightly differently for each pixel. Okay, so it can be done in two ways. One is that you do pixel 1 first, then pixel 2 first, then pixel 3 first, then pixel 4 first, then pixel and so on. And this will take a long time. This is what the laptop is doing. This is what that's why I was saying 3 minutes or something. What is actually done, and this is what graphics processing units do, is that they try to do many pixels at the same time, because there's roughly the same calculation. Why not just do all of it together? Then you do this, and you're done. And that's how the rendering is so fast. Okay, and what people realize is that the mathematics of rendering pixel and the mathematics of training and running neural networks is very similar. So you might have heard this very famous quote of Richard Feynman, that the same equations are the same solutions. Here what we are seeing is the same equation are the same circuits. Okay, and these circuits are these graphics processing units, they're just processors, which are actually designed to render images, right? Render graphics on your computer or on a phone. But these now drive a lot of the work in machine learning. And so that's what the HPC had, that our laptop was floundering at. In the meantime, to end, yeah, it has just finished, and we can see the I'll just end with whatever output it produced here. Yeah, so this is the latest one, right? 9. Oh, that is not the correct one. Oh yeah, this is also fine. Yeah. So this is slightly different from the previous one, but it's still much more reasonable question. So okay, so at least we tried to we managed to get in the half hour one machine to talk a little bit. Yeah, so let's stop there. Any questions?
Thanks for the great talk. We have time for one question if anyone has a question.
Yes. So as we know that like ChatGPT is like the main AI, but however, there are many other AI algorithms that are specialized and they perform specialized functions. But many people prefer to go for ChatGPT over those other algorithms. So why is that?
So they're not algo, you can call it algorithm, but these are basically different architectures and with different training sets. So right now we're training it on just Sherlock Holmes stories. ChatGPT, for example, like okay, there's nothing public about ChatGPT, much less public about ChatGPT than about say a model like DeepSeek. But it seems that it was trained on huge parts of the internet. That includes many technical articles, also includes a lot of novels, things like that, news. So that means that at least in terms of language, it has seen many different kinds of language, or like different types of sort of linguistic constructions. So this we already noticed, right? Like until you've seen a lot, you sort of don't start producing decent output. Even in the small example, we could see that. So that's why ChatGPT can sometimes seem to outperform specialized tools. But that is not always the case. In fact, like especially for logical reasoning, like where like you want to be completely precise, it does seem, at least right now, that it can make very serious errors, and some other models can sometimes maybe take less serious errors. And often, like in some sense, it seems as a frontier there is to try to combine algorithms, actual algorithms, which do logical reasoning with this generation to sort of do things like you first take a jump and say, okay, maybe this method will work, and then the logical part takes over and checks if it will actually work. If not, then they go back and again imagine something, and then again you check logically. So that's one thing. try to do.
Okay, let's thank him again. We'll have a quiz now. Yeah. So we have an half an hour quiz right now before the next talk.